Hello, geometers. I'm so sorry. My recording time was too long. I had gotten cut off, and so now we are back solving for this angle, this missing angle. And we had already labeled our sides, and we had said that I'm going to choose to use tan, but you could use anything. You could use sine, you could use cosine, because you have all three sides. You just have to pick two to work with and use whichever trig function works for those two. So I decided I'm going to use the opposite and the adjacent, and that is tan. And so I'm going to set up an equation that looks like this. So tan of my angle is opposite over adjacent. Now the next step for finding missing angles is actually just, you're almost there. It's pretty quick. If the tangent of an angle is this, if this is the answer, then I can find the angle by doing the inverse tan of the answer. Okay. So I press second and then tan, and then 60 over 32. You could do it as a fraction, or you could do it like division, like I did, and I get 62 degrees. In other words, the tangent of a 62-degree angle will be about 60 over 32. All right, so over here, again, I have all three sides, so I could choose to do any one I want to. I'm going to do sine. So here's the hypotenuse, here's the adjacent, here's the opposite. Sine is opposite over hypotenuse. So I'm going to write an equation that looks like this. I don't know the angle, so I'm not going to fill in there, but I do know the opposite and hypotenuse, so that's where I fill in. So sine of my angle equals the opposite over the hypotenuse. So it's basically saying I took the sine of some angle and this is what I got. What angle did I take the sine of? And so we go backwards. The inverse sine, it's kind of like reverse sine of that answer, will tell me what angle gives me that answer when I find the sine. So inverse sine 72 over 90. Now we only use inverse anything when we're finding exactly what we're finding here, missing angles. If you're not trying to find a missing angle, you don't need the inverse anything. Also, you really don't even always need it to find missing angles. It depends on what you have. If I have one of the acute angles in my right triangle and I just need to find the other one, I would just subtract from 90. 90 minus 33 would tell me what this angle is. Or over here, 90 minus 46 would tell me what this angle is. We use it when we don't know either one of the angles. We don't know either one of the acute angles, and we're trying to find it. Okay? Like for instance up here, I could have used, if I know that cosine of, we said it was C is equal to 6 over 15, I could say, okay, then the inverse cosine of 6 over 15 should tell me what C is. But here I wasn't being asked what the angle measure was. All right, so now at 8 and 9, now we're getting into finding missing side lengths. When we're finding missing side lengths, we do not use inverse functions. No inverse functions anytime except finding missing angles. All right, however, just like I did here and here, I'm still going to set up whatever my appropriate equation is. Like in the black ink, I'm going to set up an equation depending on which one I'm going to use. So here, this time I'm not given all three sides, so I'm kind of being directed. Okay, so here I am given some direction that these are the two I'm supposed to use. Okay, these are the only things I can work with. So I'm limited. I'll have to use one of them, sine, cosine, or tangent, and I have to figure out which one I have to use. So here's the two sides of my angle. That's always, the two sides of your angle are always the hypotenuse and the adjacent. So if you can identify the hypotenuse, you can find the adjacent. The one that's not part of your angle is the opposite. So in this particular one, I'm trying to find hypotenuse, and I'm using adjacent to do it. So adjacent and hypotenuse are the two sides I'm working with. That means I'm going to use cosine. So this is the equation I'm going to set up. This time I do know the angle, so I will fill in there. I'm missing one of these. I still use the same equation no matter whether I'm missing a side or an angle. So cosine of 33 equals adjacent over hypotenuse. There's my equation. Now I like to do this like cross multiplication. So this is x times cosine of 33, and I'm going to come down here for some more space. X times cosine of 33 equals 19 times 1. The next thing I always do after every step in these is ask myself, is x alone? If x is not alone, I keep going until it is. What do I mean by keep going? I do whatever I have to do to both sides to get x alone, just like I would if it were just 5x or something. This is multiplication, so I divide to get rid of it so that x will be alone. Once x is alone on one side, which it is now, that's telling me what to type in the calculator to get the value of x. So to get x, I'm going to do 19 divided by cosine of 33. I'm not clear, sorry. Notice I'm using just the regular cosine. I'm not trying to see 33 is my angle. I'm not trying to find the missing angle, so I'm using cosine, not inverse. So my answer here is 22.65 or about 22.7. There it is. All right, here's another one where we're finding a missing side length. And we have to see what two sides we're working with here. This is the hypotenuse. So this side over here, this is the adjacent side. So I'm going to use the cosine. So cosine of 46 degrees equals adjacent over hypotenuse. And now I'm going to cross multiply. I get 20 times cosine 46 equals x. Is x alone? In this case, yes. So I'm going to do 20 times, when x is alone, that's when it's time to pick up your calculator. And this tells me it's 13.89. There's my answer. Okay, so before we go on to the next problems, let me just point out these two problems are a really good example of a question math teachers get all the time. And that is, how do I know whether to multiply or divide to get my answer with these? Sometimes when I'm finding the missing length, I divide. And sometimes when I'm finding the missing length, I multiply. So how am I supposed to know which one to do? The work is how you're supposed to know. That's the reason for all of this. We always want to start out by setting up an equation, and then as we solve the equation, the whole process that we have to go through to solve it tells me how to get the answer. Okay? So when I get x alone, whatever's on the other side tells me how I will find x. Here, I'll be multiplying to find x. Here, I'll be dividing to find x, but I don't know that until I set up the equation and then do whatever I have to do to both sides to get x alone. So that's why we go through that process. All right, next. Glitchy there. Okay, the next four problems are still finding missing side lengths, but I want you to look at them and notice what types of problems those are. What is different about these as opposed to the ones we just did? Hopefully you have noticed that they all are special right triangles. These two are both 30, 60, 90s. These two are both 45, 45, 90s. So if you haven't had a chance to do these, go ahead and hit pause and try them so that you can check your answer in terms of how we do special right triangles. Okay, so let's remember real quick the rules for how things work with 30, 60, 90s and 45, 45, 90s. Okay, first off, we're doing 30, 60, 90s here. So let's talk about them. With 30, 60, 90s, first off, you want to think about the different sides of the triangle. And we tend to sort of label them like this. We have two legs, and then we have the hypotenuse. One of the two legs is shorter than the other, and it's always going to be the one across from the smaller angle. So across from the 30, opposite from the 30, this is our short leg. So then opposite from the 60 would be our long leg. Now we like to put the rules in terms of the short leg. So if we start with the short leg, to get to the long leg, we multiply by square root of 3. Starting again with the short leg, to get to the hypotenuse, we multiply times 2. We don't ever go directly from the long leg to the hypotenuse or vice versa, okay? If I don't start with the short leg, then the first thing I want to do is find the short leg. And if I'm going backwards from a bigger side to a smaller, I would divide instead of multiply. Okay, so looking at number 10. The side that they gave me is the side that's across from the 30, opposite from the 30. So that is the short leg. So that means I'm going to use the rule very directly. Short leg, which in this case is 11. 11 times square root of 3 will tell me the long leg. 11 times 2 will give me the hypotenuse. So 11 times square root of 3, the beauty of this is we could just write that. And 11 times 2 is y. All right, moving on. In number 11, the short leg across from the 30, I apologize for all the announcements, but here we were looking for what's across from the 30, and it's x. So x is the short leg, so we're not starting with the short leg in this one. This is the long leg. That's the hypotenuse. So this must be the long leg. So if we're starting with the long leg, the first thing we want to do is get the short leg. Short leg times square root of 3 gives me the long leg. So if I'm trying to go backwards, that would be divided by square root of 3 to go from the long leg to the short leg. So I'm going to take the long leg here, which is 15 root 3. And the easiest way to show the division is just to put it over, and then look what happens. So my short leg here will be 15. Then my hypotenuse is the short leg times 2. Short leg times 2 gives me hypotenuse. So 15 times 2. So those are my two 30, 60, 90 problems. And now I've got two that are 45, 45, 90. So let's talk about the rules for that. It's actually a little simpler because a 45, 45, 90 triangle is a right isosceles triangle, meaning the two angles are the same because the two legs are the same. So I don't need to figure out how to go from one leg to the other. They're the same. All right, so here's your legs. Here's your hypotenuse. And here's how we get from one thing to another. The leg times the square root of 2 equals the hypotenuse. Which means if I need to go backwards from the hypotenuse to the leg, I'm trying to get smaller, I would divide by square root of 2. So getting bigger, multiply by square root of 2, going from bigger to smaller, means divide by square root of 2. So on number 12, I'm starting with the hypotenuse. So I'm starting here, which means to go smaller, I will divide by square root of 2. So square root of 10 is my hypotenuse. I'm going to divide it by square root of 2. When numbers are both under a radical like that, I can go ahead and divide them. In other words, that's the same as if I had this. So that's square root of 5, and that's my answer for both, because remember, both legs are the same. Okay, here another one where we also have the hypotenuse. This one it's going to clean up a little bit nicer when we go from the hypotenuse to the leg, remember, getting smaller, so we divide by the square root of 2 instead of multiplying by it. It's a lot like number 11, really. If I divide this by square root of 2, it just cancels. So x and y are both 9. All right, next up. These two questions are questions that are basically from the Pythagorean converse, but also the triangle inequality. So let's look at those. First thing I want to look at is number 15. Number 15 says, what type of triangle is formed by the side lengths 6, 8, and 10? Okay, the Pythagorean converse says, let's find a squared plus b squared, where a and b are the two smaller sides. So that would be 6 squared plus 8 squared. 36 plus 64 is 100. Then find c squared. C has to be the biggest side. So that's 100. Now, make a decision based on this number and how it compares back to the a squared plus b squared. So your decision is based on the c squared. If this number is bigger than that one, that would mean it's an obtuse triangle. If this number is smaller than that one, that would mean it's an acute triangle. If it's the same, like it is here, that means it's a right triangle because a squared plus b squared is equal to c squared, which is the Pythagorean theorem. So if a squared plus b squared equals c squared, it's a right triangle. Now the reason I wanted to do this one first is because this one has sort of a little bit of a catch. There's something called the triangle inequality, okay? And I'm going to just write it up real quick. That says, if you have a triangle and it has 3 sides, then it's always going to be true that any 2 of the sides have to add up to be more than the 3rd side. Notice here, I'm not squaring, just plain add the 2 sides. If that's not true, then it can't, those 3 lengths can't form a triangle at all. Okay, so this is stuff that's true in every triangle. And if it can't be true, then those 3 lengths cannot form the sides of a triangle. And look what happens right here. 7 plus 9 is not bigger than 24. 7 plus 9 is 16. That is not bigger than 24. So this is not a triangle. In other words, what would happen is if I had a side length that was 24, and then I attached a 7 to one end of it, and a 9 to the other end of it, they would never touch. They would not be able to meet. That's why it's not even a triangle at all. So that's called the triangle inequality. And usually when you're asked questions like this, it says, determine whether the 3 sides could be the size of a triangle. If so, what type of triangle? And that's where we use this part. Okay, so just keep that in mind. I'm not entirely sure that whoever made this meant for this to not be a triangle. All right, now we get into some angle of elevation and depression. It says the angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 7. I don't even understand what that says. 17 degrees, I guess. It has some sort of little thing in the middle of it. I guess that's just 17 degrees. Okay, and I'm going to try and, hang on one second, let me see if I can adjust this and make it wider. There we go. Okay, so we got a kicker on the football field. So he's on the ground. There he is. That's his beautiful golden foot. Top of the goalpost bars. Okay, so we're talking like, here's the goalpost. From his foot to the top. That's the kind of situation we're talking about here. So this is my right triangle. One side is the ground. Let me make that a little longer. One corner is the top of the goalpost, and his foot is one, or where the ball is. Actually, it says the foot, is the other corner. So the angle of elevation from his foot means down here. Angle of elevation is always at the bottom of the triangle because the idea is you have to be at the bottom to be able to look up. An angle of elevation is looking up from the horizontal. If he is standing 131 feet from the base of the goalpost, well, let's pretend that's the base. So 131 feet. How tall is the goalpost? So this is what we're trying to find, is this height right here. Okay, once we've figured out how the picture works, it's just like any other problem where we're trying to find a missing side length. We say, okay, which sides do we have? This is the hypotenuse. This is the adjacent. So this is the opposite. So we're working with the opposite and the adjacent. The trig function that works with opposite and adjacent is tangent. So this is the kind of equation I'm going to write. Tangent of my angle, which I do know here, so I fill that in, equals opposite over adjacent. And now I cross multiply. 131 times tan 17 equals x. Is x alone? Yes. That means it's time to pick up the calculator. 131 times tan 17. That gives me 40.05. It doesn't tell me what to round to. So I'm just going to say 40.1, and I believe it's feet. Yeah. So x is about 40.1 feet. Next question. A dog is standing 5 feet from the base of a tree looking up at a cat that has climbed 16 feet up the tree. So we have a tree. Somewhere out here we have a branch. And there's a cat. Y'all are loving my art, aren't you? That's the cat. The dog is standing 5 feet from the base. So that's the 5. Here's the dog. Looking up at the cat. The cat has climbed up 16 feet. What is the angle of elevation from the point the dog is standing on the ground to the cat? I'm not sure about the wording there, but angle of elevation is always at the bottom. So in other words, we're asking, what is this angle? All right, so again, we've set up an equation. For this angle, here's the hypotenuse. Sorry, I forgot my right angle. It's right there. So this is the adjacent, and this is the opposite. So I'm working with the opposite and the adjacent. Opposite and adjacent is tangent. So that's the equation I'm going to set up. So tan of x, and by the way, you might notice a lot of times your application problems use tangent. There's a reason for that. Let's finish this problem. We'll talk about the reason. What am I trying to find here? I'm trying to find the angle. Remember, the angle, the missing angle, is the time that I actually do get to use those inverse functions. All right, so x is going to be the inverse tan of 16 over 5. So inverse tan of 16 over 5 is 72.6. Usually for angles, we round to the nearest whole number degrees. So this would be about 73 degrees. Okay, the reason we often use tan is because if this dog is looking at this cat, the hypotenuse is not a real thing here. Now, sometimes you'll have a problem where, like, you know, a person is flying a kite, and then the diagonal line here is actually a piece of string. Okay, it's something we could measure. But most of the time, it's what we call a sight line or line of sight. This is just like the path of their vision. Kind of like if they had laser vision and they were looking at each other, that's the only reason you would see it. Same thing here. Guy looking up at the top of the goalpost, laser vision. Okay, so we don't really, that's not really something we need to measure a lot. Height, we need to measure. Distance along the ground, we need to measure. So very often we end up working with just those and don't need anything but the tangent on application problems. Not all the time, though. Okay, number 18 is a little bit more challenging. Building A is 480 feet, tall. Building B is 654 feet tall. If the angle of depression from the top of building B to the top of building A is 42 degrees, how far apart are the buildings? So thinking about how to draw this can be a little bit of a challenge. Let's put them on the same ground, which I'm sorry I just made hilly, but it doesn't pretend it's not. Okay, building B is shorter. Excuse me, A is shorter. Okay, this has a height of 480 feet. That distance is 480 feet. Building B is taller than that. It has a distance here, a height of 654 feet. Okay, angle of depression from the top of building B to the top of building A, meaning angle of depression is always with the horizontal. So this is the angle right up in here. So this is 42 degrees. Now, we usually take that angle of depression when we make it an angle of elevation instead. So this is my right triangle, and it's going to be right there. These are alternate interior angles, so they would always be the same. So how far apart are the buildings? Now, what I can do here about this triangle, I can figure out what this distance is, because I know the entire distance here, and I should have put it somewhere else. Let me put it somewhere else. This entire distance is 654. So this is level with the top of the other building, which is 480. So this part right here is the amount that this building B is taller than building A. It's how much taller building B is than building A. So I'm going to subtract 654 minus 480. Okay, 174. So this is what I have right here. This is 174. So I'm going to just take that off the page there because now I really don't even care about buildings or anything. For a second, I'm going to clean it up a little bit. This is what we've got going on here. Now what the question asks me is how far apart are the buildings? So that in this picture is this distance. So it's the bottom of my right triangle. So that right here is what I'm trying to find. Okay, this is my X. This is what I want to know. Now it's a problem just like many others we have. We can ignore the buildings and say, okay, here's my angle. It has two sides. One's the hypotenuse. One's the adjacent. This is the opposite. Now, which two sides am I working with? I'm working with opposite and adjacent. So just like we were talking about just now, it's tan again. Don't assume it's always tangent, but it does seem to be a lot of the time, right? So tan of my angle is opposite over adjacent is the equation I'm going to set up. Tan of 42 equals opposite over adjacent. Now I cross multiply. This is like over 1. X times tan of 42 equals 174 times 1. X is not alone, so I have to get it alone. So I'm going to divide both sides by tan of 42. And I get X is now alone, and so now it's time to pick up the calculator and type in whatever's on the other side, which is 174 divided by tan of 42. And I get 193.25. I'm going to round that to the nearest tenth and say 193.2. So that's 193.2. I believe it was all feet. Yep, they are that far apart. That's this red distance right here. Okay, so I hope this has helped. If you have any questions after watching this and want to ask me, feel free to email me, message me, drop it in the comments, whatever. Thanks so much.